The universe is a vast and mysterious place, and for centuries, humans have been captivated by the possibility that we are not alone. The search for life beyond Earth has been a fundamental part of our scientific endeavors, and thanks to revolutionary advances in technology, this search has entered an exciting new era. Among the most groundbreaking instruments in this quest is the James Webb Space Telescope, JWST, an astronomical marvel designed to peer into the cosmos with unprecedented clarity. In this new chapter of space exploration, humanity stands on the cusp of what could be one of the most profound discoveries of all time, the detection of artificial light on distant exoplanets. If confirmed, it would provide direct evidence of technologically advanced life on another world. This isn't just a concept from science fiction, it is becoming a reality, and the implications of such discoveries are nothing short of staggering. One of the most extraordinary capabilities of the JWST is its ability to detect faint infrared radiation from distant objects in the universe. The JWST's mid-infrared instrument, MIRI, is particularly suited for this task, as it is designed to capture infrared light emitted by faraway celestial bodies. What makes MIRI so special is its sensitivity to infrared radiation, which can reveal a wealth of information about distant planets, their atmospheres, and potentially, even the presence of artificial light. For the first time in history, we have a tool that can discern light from large cities, industrial complexes, and other man-made sources on planets light years away. This revolutionary breakthrough offers the tantalizing possibility of detecting techno-signatures, evidence of intelligent civilizations, on planets that orbit stars far beyond our own solar system. The idea of detecting artificial light on another planet raises an array of fascinating questions. Could we truly observe cities or advanced technological infrastructures on distant worlds? And if so, what would these lights tell us about the inhabitants of those planets? It sounds almost unbelievable, but the technology to make these observations is here, and it is rapidly advancing. The JWST is already proving its worth in this field, and scientists are eagerly awaiting even more data from this remarkable instrument. Proxima B, a planet in the Proxima Centauri system, has long been a subject of intense interest for astronomers. This planet, located just over 4 light-years away from Earth, is considered one of the most promising candidates for the search for extraterrestrial life. Proxima B resides in the habitable zone of its star, Proxima Centauri, which means it could potentially have conditions suitable for life. The JWST's capabilities are opening up new possibilities for studying this distant world in unprecedented detail. With its ability to detect artificial light, the JWST is enabling scientists to look for signs of technological civilizations on Proxima B. This is a game-changer in our search for life beyond Earth, as it provides a new way to detect the presence of intelligent beings without needing to rely on indirect methods like the search for biosignatures alone. But detecting artificial light is just one part of the puzzle. To fully understand what life on an exoplanet might look like, we need to study the planet's atmosphere and surface in detail. This is where the JWST's other instruments come into play. The telescope's ability to analyze the chemical composition of an exoplanet's atmosphere is vital for understanding whether the planet could support life. The presence of gases like oxygen, methane, and carbon dioxide can offer clues about the planet's potential habitability. However, what makes the JWST so revolutionary is its ability to detect these biomarkers in the atmospheres of distant planets with incredible precision. It can even identify the presence of ozone, a gas that is strongly associated with biological processes here on Earth. This capability opens up the exciting possibility of discovering exoplanets that might harbor life, whether simple organisms or more complex forms of life. As remarkable as the JWST is, it is not the only tool in our arsenal. The Extremely Large Telescope, ELT, set to begin operations in 2028, will provide another powerful way to examine exoplanets. Located in the Atacama Desert in Chile, the ELT will be the largest optical and near-infrared telescope in the world. Its 39-meter primary mirror will give it unparalleled resolution, allowing it to study the atmospheres and surfaces of exoplanets with incredible detail. The ELT will be able to detect faint signals from distant planets, including the potential presence of artificial light or other signs of civilization. This next-generation telescope will complement the work of the JWST and take our understanding of exoplanets to new heights. the ELT will be particularly useful in studying planets like Proxima B. While the JWST is ideally suited for observing infrared radiation and studying the early universe, the ELT will provide us with detailed optical and near-infrared images. It will be able to correct for atmospheric distortions using adaptive optics, which means it will produce sharper, more accurate images of distant exoplanets. With its high resolution and light sensitivity, the ELT will be able to perform in-depth spectral analyses of exoplanet atmospheres, identifying key biomarkers like water, methane, and carbon dioxide. This will allow scientists to learn more about the chemical makeup of exoplanet atmospheres and potentially identify planets that are capable of supporting life. But it's not just artificial light and atmospheric biomarkers that we should be on the lookout for. The search for life on exoplanets is also focused on detecting biological activity. The concept of biosignatures, indicators of life in the form of chemical imbalances or specific gases, has been a driving force behind much of the research into exoplanet habitability. The JWST, with its ability to perform high-resolution spectral analyses, is already proving its potential in this area. For example, the telescope recently detected the presence of methane and carbon dioxide in the atmosphere of an exoplanet named K2-18b. This discovery raised hopes that the planet could be habitable, as these gases are commonly associated with biological processes. One of the most exciting prospects in the search for life is the ability to detect plant growth on distant worlds. Plants, as we know them, are essential for life on Earth, and their ability to photosynthesize is a hallmark of biological activity. The JWST's ability to analyze the reflective properties of light coming from an exoplanet could provide direct evidence of plant life. This technique, known as the vegetation red edge, VRE, looks for specific patterns in the reflected light that are associated with chlorophyll, the pigment responsible for photosynthesis. If the JWST can detect these signatures on a distant planet, it would provide a major breakthrough in the search for life beyond Earth. However, detecting plant growth is not easy. It requires extremely precise measurements and high-resolution data, and the presence of atmospheric disturbances or noise can interfere with the signals. Despite these challenges, the JWST is already making strides in this area. As our understanding of how to analyze exoplanet atmospheres improves, we will be better equipped to identify potential biosignatures and look for signs of life beyond Earth. As exciting as the JWST and the ELT are, the future of exoplanet research doesn't end there. One of the most promising upcoming missions is the LUVOIR, Large Ultraviolet Optical Infrared Surveyor, telescope. This future space telescope, set to launch in the 2030s, will be designed specifically to study exoplanet atmospheres with even greater precision than the JWST. LUVOIR will be able to cover a broader range of wavelengths, allowing it to detect a wider variety of biosignatures, including those associated with plant life. It will also be able to isolate and analyze light from exoplanets in unprecedented detail, further advancing our search for signs of life beyond our solar system. LUVOIR will also be able to carry out direct imaging of exoplanets, allowing scientists to study their surfaces and atmospheres with incredible clarity. This could provide us with the first direct images of Earth-like planets, showing us what their landscapes might look like and whether they have the potential to support life. The ability to observe these worlds in such detail will be a game-changer in our search for extraterrestrial life, and it will provide us with the tools we need to answer one of the most profound questions humanity has ever asked: are we alone? The development of these cutting-edge telescopes and instruments is happening at an astonishing pace, and they are poised to change our understanding of the universe. As we continue to explore the cosmos, the possibility of discovering intelligent life on distant worlds becomes increasingly likely. We are on the brink of a new era in space exploration, and the future of the search for life beyond Earth is brighter than ever. With each new discovery, we are getting closer to answering one of the most profound questions in science: is there life elsewhere in the universe? And if so, what will it mean for us as a species? As scientists continue to refine their techniques and develop even more advanced technologies, the dream of discovering intelligent life on other planets will become a reality. Whether we find artificial light on Proxima B, detect plant growth on a distant exoplanet, or capture the first images of Earth-like worlds, one thing is certain: humanity's search for life beyond Earth is just beginning. And with each new discovery, we are one step closer to unraveling the mysteries of the universe.